In this video, I'm going to show you how you can calculate your network address ranges that mean all the major ranges that you have to for a network. This is a very simplified form of doing it. Most network books and network classes try to teach you in IPv4 how to basically do this with 32 bits. I'm going to show you that we don't need 32 bits. It's only 8 bits that count. So this is network addressing in the world according to Dave. Let's start with the basics. Before we can look at this, we have to understand what binary is and how it looks and works. And basically in binary, we'll look at 8 bits since that's what we are. And the first bit has a value of 1, the second bit is 2, the third is 4, 8, 16, 32, 64, and 128. These should be pretty straightforward. How we represent a decimal number in binary is done fairly straightforward. We basically, in this case, to document or to show 156 in binary, it would be 0011101. Another way to look at this is basically it'd be 4 plus 8 plus 16 plus 128, and that's how you come up with your binary number. Some of the binary math and stuff you would need to do in network calculations, we're going to just gloss over, but it's easy to review a lot of this, but we'll give you the basics. So let's talk about the basics of network addressing. Again, we're dealing with IPv4. In IPv4, network address is 32 bits long, and 32 bits is hard to understand and remember, so what we do is in the human readable form, we break them down to what we call a dotted quad. A dotted quad is basically 4 numeric values of 8 bits, and it has a period or a dot between each. That's where we come up with that. These 4 numbers would basically be between a range of 0 and 255, which is all 8 bits can represent. A network mask, though, is what we use to separate the network bits of the address from the host bits of the address. We use it to calculate what is part of the network and how and what is the actual host address. It's very simple on a network mask, and I'm going to tell you it's as simple as, remember, all the ones are on the left-hand side, all the zeros are on the right-hand side, and they have to be in that order. So in other words, the ones are, one of my favorite words, contiguous, meaning they're all together. They're not separated. So basically having 1100 is a great way to represent it, whereas a 101 is not what a network mask could look like. Okay. Basically, we can count the number of hosts that we have very simply, because the number of hosts on any network equals 2 to the n power, where n is number of host bits. And we'll get into this in a moment or two, so you'll get to see that. The way to look at this is basically there's going to be only 9 basic values that you can use in a network mask. These values are from 0 to 255, and this chart here in my methodology of using how to calculate is really an important chart to memorize, because if you memorize this chart, everything else becomes very easy from here on out. So it's very easy for us to understand. The way a mask would look is very simple. You have 255 on the left, you'll have 0 on the right, or you'll have basically one of our mask values in it, and that's how we figure this out. So examples of what this would look like is like 255, 255, 128, 0. That matches because 128 has just for the high order bit set, or the 8th bit set. Everything else is 0. So as you can see, 1s are all on the left side and 0s are all on the right. Just like the next example, 192.0.0.0. Same thing. We have all the 1s there, and they're in the first octet, 0s the rest away. Or we have a very common way, 255, 255, 255, 224. And again, all the ones are on the left and 0s go on the right. So this gives us a great way to look at this. Okay, this leads us to our next thing, which is what we call a variable length subnet mask. or a slash notation or prefix notation. So instead of putting together both an IP address and then mask, we will just represent it as one number with a / between the two values. So in this example, 192.168.0.1/24 means that we have 24 network bits. So that means the first 3 octets will always stay the same, only the last octet is the host value. So it gives us a great way to see how we do this. A way to look at this in binary is in this address, you'll see we have the 192 as the first octet is a 11 followed by zeros in that octet. 168 would be a 1010100000, and then we have, of course, 1 with 7 leading zeros and a 1 and then 0 at the end. And then the mask would be 255 255 255 0, because that's our 24 bits. If you look at that, you have 3 times 8, which is 24. So there's 24 ones followed by 8 zeros, and that's how that works. The next thing that we have to look at is basically a logical operator. It's called the AND operator. It works on binary numbers or on bits, basically. And what it does is it says that if both bits are 1, it returns 1. In any other case, it returns a 0. So a simple chart to let us see how that works is this above here. If we're looking from left to right, the first row, 0, 0, will return 0 because both aren't ones. And if we have a 0, 1, that returns a 0 because, again, not both are ones. And then we have a 1, 0, again, 0. And then the only one to return 1 is a 1 and 1. And again, 1 represents true and 0 represents false in most binary calculations. So let's take a look at this and how this would work. So let's say we're taking a simple binary number of 101, which is 5 in decimal. We want to AND that with a binary 3, which is 011. If you look at the columns here, you see that the first 2 columns have no duplicate ones between the 2 numbers. So they come out to 0 when we add them. And them, only the last one comes out to 1, and this is how we get it. So a way to look at it is if we did a 5 and then AND 3 in decimal, that means we would get a value of 1 decimal. So let's talk about how network addresses work. Well, there's 2 special addresses, and they can't be used by hosts, but they're very important. We have to have them. The first one is the network address, and that's always the very first address of the network. We use that to address the network. The last one is the highest host value or host on the network. That becomes a broadcast address. That is how we talk to all hosts on the network, because we have to sometimes query all the hosts to ask for information or something, and that's how that works. So for example, if we have a 192.168.250.0/24, the network address would be 192.168.250.0. The broadcast address would be 192.168.250.255 because that's the highest one there. And we'll talk about those calculations here in just a second. So what we have to do is figure out how do we calculate the subnet mask from the prefix. That's the first thing we have to do. I'm doing it this way because if you don't have a prefix, you'll have the mask, so you don't have to calculate. But this gives us our first step that we have to look at. So what we do is we take the number of the prefix and divide by 8. This will give us an integer number. So for example, if I have 22 and I divide that by 8, that's going to leave basically 2. So that means I'm going to have 2 octets of 255. Once I get to that point, then I have to calculate what the number of bits left over. If you go back to the chart that I gave you before earlier, this is why we have to memorize the chart. It tells us exactly how many bits are left over and what the valid subnet mask value would be. So let's take our example and look at it here. /22 prefix. What that means is 22 network bits. So if we take the 22 divide by 8, that's 2. So we get 2 octets of 255. Now what we do is we say, okay, what is 2 times 8? That's 16. So we basically take the 22, subtract 16 from it, because those are the bits we've used, and that leaves 6 bits left over. If we reference that chart that I showed you earlier, that means that 6 bits for the network comes out to a 252. So our subnet mask becomes 255, 255, 252, 0. So now we've just converted our prefix number into a subnet mask. So now at this point in time, we can start to calculate the subnet address. And we can calculate the subnet address, unlike what most books in networking try to do, is show you how to do all 32 bits. Basically, I'm going to show you we got 75% of the problem known. That means we don't have to calculate it. 3 of the 4 octets we can think of very clearly without doing any hard math. We just know what it is. So, for example, wherever in the subnet mask you have 255 in the mask, it's going to equal the same number of the IP. That is setting up your network address. Wherever the subnet mask has a 0, we know that the network address is going to have to be a 0, because anything and it was 0 is always going to be 0. So, after that, all we have to do is calculate the one octet we don't know. And so let's go back to the example we've been looking at. If we have a value of 250 and we have a subnet mask of 252, if you look here, the red ones show you exactly where we go. That means we have the first 5 ones are the same across both numbers. If we AND this together, we will exclude the last 3 bits altogether because they're not both going to be 1, so we can't get anything but 0. If we do that, then that means that, plain and simply, we've ended up with a 248 for the network mask. So, putting all this information together, what we do is we know that the basic subnet that we're looking at, or the host we're looking at, is 192.168.250.24. We know we have a subnet mask of 255, 255, 252, 0. Well, then we can say, just looking at what we know, the starting point of what we do know are the 3 octets, which would be 192.168. We don't know the 3rd octet, and 0 at the end. That goes to our first step, where we have the same numbers in 255 in the mask and 0 where we have 0 in the mask. Now all we have to do is we just AND 250 with 252, which we did up above, which is 248. So once we apply this, the only octet we had to do any calculations on ends up being 248. So we know that the network address will be 192.168.248.0. So we've already now calculated the network address. The next step we want to do is actually calculate the broadcast address. Well, again, very similar to the network address, we know 75% of this without any calculations. That means 3 of the 4 octets are solved without even hardly thinking. Wherever there's a 255 in the mask, it's going to end up with the same number as the IP. Wherever there's a 0, though, unlike what happened with the network calculation, this is going to be 255 for the broadcast because we're going to the upper end. We're flipping the bits, in other words. So, then, how do we calculate the 1 octet we don't know? This is a little more complex because what we have to do is we have to find the number of hosts in the network. And basically what you do is you'll take the network bit, and if you remember your binary, you'll take whatever bit that is, and you'll subtract 1 from it, and that'll give us the value of how many hosts we have on the network. Once we know that, then we take that number of hosts minus 1 and we add that to the starting network octet. If that sounds confusing, it really is not. So let's look at our example. Right now we know that our example is 192.168.250.24 and the mask is 255, 255, 252, 0. So we know the starting point. Looks very similar to what we did with the network addresses. 192.168. Don't know the 3rd octet, but in this case the last octet instead of being 0 is 255 because we're going to the high end. So now all we have to do is add our calculation. To add our calculation, we'll take the number of hosts we have and minus 1 from it. Well, if you look at our chart that we did before with 6 bits, which is what we have over there, that means we have 2 bits left over. Looking at those 2 bits, if we basically turn those on, that means we have a value of 3. Okay, another way to look at it is look at that last bit in the subnet mask, which would be value 4, subtract 1, we have 3. That gives us the number that we have to have. So we add this to the start of the network address. So now we have 192.168.251.255, and that's our broadcast address for this network. So now comes what we really need to know. What is the first usable address of the network? It becomes the network address plus 1. What is the last usable address on network? It's the broadcast minus 1, because again, we can't use those two IPs. So looking at our example, we know 192.168.240.0/22 gives us a first usable host, 192.168.248.1, and a last usable host of 192.168.251.254. And that's applying all the math that we've done so far. So what does all this mean and how do we apply it? Let's take you through an example. We'll start with an IP address of 56.150.234.138, and we're going to do a /18, meaning we're going to have 18 bits for the network. So we'll calculate the mask first. So what we do with the mask is we basically do our math. We take our 18 divided by 8, that equals 2, so we know the first 2 octets are going to be 255. What we do next is we basically then take 2 times 8, which is 16, subtract that from the 8. We know we have 2 bits for the network mask, and when we look at that, you'll see that we come up with a value of 192 out of our chart. Again, this chart's very important to have memorized because it helps you a lot. So now we've just converted the /18 into a subnet mask of 255.255.192.0. This makes the rest of our calculations become very easily, because what do? Well, we'll calculate the host address. Well, the host address becomes 56.150.234.138, and it's going to have a mask of 255.255.192.0. So let's start our calculation. The known information we have, very simple. The network will be 56.150. Not sure the third octet, and the fourth octet is 0. The broadcast is going to look very similar. It's going to be 56.150, not sure the third octet, and 255. The reason this works is because both your network and your broadcast have to be on the same network, so we know those match. So this becomes very easy for us to calculate. So now let's look at the one network octet we really don't know, which is the third one. So what we have to do is we have to figure out, if we take 234 and AND it with 192, what do we come up with? Well, basically, if you look at the binary value here, it's very easy. We get the first 2 bit set, which means that we have a 192. So we know that basically the network octet that we didn't know will be 192. So now we've just calculated our network address. It's going to be 56.150.92.0 is our network address. Our next thing is to figure out what is the broadcast octet. Well, the broadcast octet is going to be slightly different because, again, what we're going to do is we're going to look for the last value of the very last bit that we use. In this case, if you notice, our network bit is using the last 2, so 64 becomes the value of that last bit. If we subtract 1 from that, that's 63, and if you look at that in binary, that basically is having 1s in bits 1, 2, 4, 8, 16, and 32. So it makes the calculation very easy to do. So we know that we have basically 63. So all we have to do is add 63 to our network octet, which we already know is 192 because we just calculated that. And if we do that, then that means we've now calculated the broadcast address as 56.150.255.255. And we've calculated our entire broadcast address. So now we've got the network and the broadcast address. So where does that fit when it comes to the first usable host? Well, we add 1 to the network address, so it's 56.150.192.1 is our first usable address. And our last usable address is 56.150.255.254. And now we have our last usable. So just to review, how do we calculate it? We did all the calculations. We ended up with 56.150.192.0 for the network address, 56.150.255.255 for the broadcast. We have the first usable host as 56.150.192.1, and we have 56 150, 255, 254. That's basically how you calculate it. I have another video that you can follow up on that will show you how you can subdivide or subnet a network, and that'd be worth following up on. I'll put that link down below so you can actually see that.